plan on finishing up the virtual memory lab demonstration, and right now we were still in analyzing the memory map and who's using what, and whether those resources are productive use or whether they are memory leaks and things that aren't being used anymore. Also want to finish up and do the swap lab. But in order to play with the out-of-memory killer and the swap issues, I need to get that defragmentation, the compaction, turned off. I'm going to do that in a little bit. Now let's take a look. I'm going to go share my desktop here. Things have changed a little bit on the system. I am running different things right now. I just want to go through my drill again. SAR1 space 5. Everything looks healthy there. A little bit of I/O wait time going on, and we know right now that that was from the code 5s. We were able to do an echo T into processor Q trigger. Had to wait about 5 minutes, and then we were able to see one code 5 that was sitting on an IO underscore sched. *Q 1 space 5. We do have a high load level. This is a 64 CPU system. I got twice the number of processes waiting to do work than CPUs available. Now that load average included the D options. If I do a PS-EL and grep D, that shows all these things that are in the D state. There's the D right there. And I'm going to count them. 130. That's where my load level is. So *Q. Showing I don't have much on my CPU utilization. My run queue is real small, less than the number of CPUs, but my load level is high. In fact, 15 minutes ago was in the 150 range. But again, I had memhogs and code 4s running at that time, which I've cleaned up since. So that's CPU. Let's take a look at memory. Notice this time I am over-committed on memory. I have a 122% commit. That means that I have reserved more than my limit. Only 79% of my memory is actually being allocated, but I've got 122% of my memory being reserved. I have to be a little careful there. We need to come back to this in the overcommit stuff. But I'm going to cat /proc/meminfo. And we were looking at the committed AS space versus the commit limit. And notice that my commit AS space is larger than my commit limit. But again, we have overcommit capability. Mallocs are going to be successful. But if I don't use the memory, it doesn't matter. If I do use the memory and I'm all allocated, then the out-of-memory killer comes in. If I turn off overcommit, we're going to do that in demo here and echo a 2 into the overcommit memory sysctl parameter. Then when I try to reserve and is greater than the commit limit, it will fail. I cannot overcommit memory when overcommit memory is at 2. We're going to come back to that and demonstrate that. Okay, *DP 1 space 5. I do see SDB is busy. I fired that up during break. Let's take a look at what SDB is. If I do a DF, SDB 1 at least is data 2. Let me do an F user on -UVM on /data 2. This will show what is open in that file system, but not necessarily what's doing I/O, just what's open. And I see all those code 503s. Okay, now I'm going to do an IO top. There's those code 503s, but there's also something else here. MD5 sum, generating a checksum on dev SDB. So *DP does have a couple of things going on with it. Let me bring up top disk. Again, I can see SDB has large reads and a little bit smaller writes. The reads are in a 512 kbyte average size. No writes going on right now. Okay, good enough. So, CPU memory disk, I didn't check swap -S 1-5. Nothing out on swap. And again, memory's not full either. So now I want a cat/proc/mem info. I do have, what do we got there, a 12 gig slab right now. I still have that 131 gig of shemem, 13 gig slab. A non-huge pages, I do have 28 gig right now of a non-huge pages. This is our transparent huge pages. Default page size was 4 kbytes, but the default huge page size is 2 megabytes. I can boot the system with a huge page size parameter that can change the page size to larger pages up to 256 meg. If I want to go larger than 256 meg, then you have to use SGI software on a UV called Super Pages. I don't see any dirtier right back here. Again, my Anon pages itself is at 28 gig. Nothing maps, so there's nothing there. I do still have half my memory in shemem, ls-l on dev shemem. There's that big file. I also still had large buffers. So my buffers was at 60 gig at the time. And if I look at active and inactive, most of my memory is inactive. In fact, it is inactive Anon. Okay. And that is big enough to be my dev shemem. And I do have some inactive file cache as well. That looks to be big enough to be my buffers. CPU memory disk file system, the slab was small, but let me just do it slab top -S-C. I would expect buffer head to be big. There, the buffer head is at about 2 gig. When I trim and get rid of the raw I/O that's in buffmem and get rid of the dev shemem, that buffer head will go down. File system buffer cache. Looking at the buffer, I'm going to do an LSOF, and let's grep for /dev/SDB. Taking a little bit here.
Oh, but okay, yeah.
There it is. I can see that MD5 sum has /dev/SDB open. And here's, can't really see it, the size of the file. Let's see. Let me do an LSOF in the head.
Okay. So you have 2 sockets per blade, right? The blade 0 has socket 1.
Just waiting for this to come back.
Are they counted consecutively as well or not? Yes. Okay.
Right here was the size. Not sure. I guess nowadays it's putting it into hex. I don't remember doing hex before. But this was a raw file versus an actual file, so that might be a difference as well. Let me do an strace-f-p on 51194. And there I can see the read. Now, I don't know what actually got open. I don't have file descriptor 3 here. But I can see it's reading in 32 kbyte chunks. In from the disk. So CPU memory disk, file system buffer cache, IPC, IPCS-AM. There's nothing really big there. LS-L on dev shemem shows that I do have a big file there. And then NumLink, link stat-UV. It says UV statistics are not active at this point, so I'm going to do -A. And now I should be able to get statistics from, let me go to my, hang on, let me go to PM chart.
All right.
And if I flip to NumLink, I see that I now am getting NumLink statistics on a per port basis, anywhere from 50 megabytes to 200 megabytes, 180 megabytes. Again, you can look up the specs of your particular node board to figure out what the bandwidth is on a NumLink port. So looking at the system, CPUs don't have much work, nothing on swap. We're pulling apart memory now. I do see a lot of reads going on, which we've identified primarily coming from MD5 sum, which was doing raw IO into /dev SDB, reading it for a checksum. Yet memory, this is what this demo is all about. Let me get free back in and map back in. So it looks like, again, I do see a little bit of a slab trim that occurred here. I am seeing this buff mem here is what's growing. The yellow there is anon pages. I also had huge pages on top of that too. And then the free. Now again, this system had 256 gig of memory, but I'm already at 280 showing up when I add all these together. So you have to be careful about things being counted more than once. I'm not going to care that that's more than I physically have. Do I have anything mapped? I'm not seeing anything mapped. Let me do something here. So if I run that program, it is doing shemem stuff. Not seeing much of a change here. I do see system time associated with it. Let's see if we can catch that. Perf top. Raw spin lock. Let me see if I can do a perf record -A-G before it's too late. So we have system time associated with this code 9 running. I want to know what it is. That looks good enough to me. I'm going to bring up top as well. Of course, I'm suspecting some garbage collection, compaction. I do see an A.out run. I see code 9's running. I do still have 14% system time, but I'm not seeing any sort of migration thread show up there. Let me go to the paging group. I don't see any change. Well, there was some compaction occurring. I can see the mapped going here. It is growing. That's the mapped field right there. And it will grow with the cached. Again, shemem is going to show in both the cached and in the mapped. And so all of that system time is gone now, and it looks like my code 9s are running. I was able to capture some of that. So let me do this. I think it was here. I got a perf.data. Let me do a perf report --stdio.
Original one, the original 65,000, 65,000 entry socket table.
Just finding a couple things it doesn't like, but let me do a more on X now. So most of that code 4, 70% CPU time was in walktree, which is where we're generating and creating the table, the array. you save, and I can see that there was some memory compaction going on here during that interval. But memhog seemed to have caused it, not the code 9s. I want to find the code 9s. There's the code 4s. I don't see any code 9 in there. So let me try another one here. Maybe it was in home. There's the perf data that I was using. That's the one that matters to me. Let me do a perf report here. I was in the wrong one before. So there's the code 9s, and they're in a raw spin lock. I'm going to expand that. So I don't see, none of that system time was due to compaction. So I'm seeing raw spin lock 48% of the time, which was this Shem get page GFP. And we got this spin trilock page. So everything is page faulting into Shemem to get it. Find page. There was one here that was in a finish wait, waiting for a locked page to come out. More code 9s in that get page GFP. A put page. Add page cache locked. Locking the page. And here it's clearing the page, zeroing it out. So that's what that system time was. So now that thing is running. Now I'm going to go in here. I'm going to remove big file, which is the Shemem aspect that we have. Now these code 9s also have Shemem attached to them. Let me go to the memory one here. So here I can see the cache field go down. How about swap? Nothing on swap yet. We never pushed a swap because that compaction prevented me. So I've gotten rid of the cache clean that included the Shemem field. I do still have buffmem there. Let me do a BC free -A. And that is also clearing away the buffmem. Only thing I have on top of that, this is the anon pages. This is transparent huge page. And this is the mapped. I want to PS-E. I'm going to leave those code 5 still going. And let me do a kill. No, I don't want to do that. Let me get rid of the A dot outs. Oh, before I do that, if I bring up top, notice I've got a process stopped. A stop process is in a pause state. I can find what is stopped. I'm going to do a PS-EL grep. The state will be a T instead of an R, an S, or a D. And I see an A dot out that is stopped, and it's rather large in memory, too. Looks like 26 gig for a process that's stopped. I'm going to do a kill all A dot out. Let me go back to the memory map, and I can see that some of my memory from that A dot out got recovered. And this huge anon pages is gone. There's a little bit left. That A dot out cleaned things up, killing A dot outs. Let me bring up top. I, however, do still have a stopped process. When a process is stopped, it does not see signals. Let me do a PS-EL. And there it is. It is waiting for a signal. It will not see the signal until it starts again. A kill-L shows my signals. The stop, or a Control-Z, which was done here, is a signal 19. Now, a signal 15 is your normal kill, but that is not a hard kill. A program can sit there and wait. Let me do a man 3P signal. The signal library call can say, if the signal comes in, jump off to this subroutine, and that subroutine can usually do things like close off files, remove files, write a checkpoint file, do various cleanups. And it is the responsibility of the program to remove shared memory, shared dev shemem and IPCS shemem stuff. It's up to the program to remove that. If I do a kill 9, it will still get the kill 9, but then it won't have a chance to jump off to this function and clean up after itself. Not all applications have a signal handler in them. So if I actually do a kill-L, this program is still sleeping. If I do an 18, that will continue it. And then it will see the signal. So there's my A.out running. Let me do a, actually, let me just kill it. Kill all dash 18. Let's see if we can see what happened up here. And there I can see a little bit of memory that was freed up from that as well. And now that process is gone. Let me try that again, memhog. Let me go 100 gig here. You can put standard out and standard error into /dev/null. Let me fire off 2 of them, a couple of them. So there's the memory growth. Notice I am getting anon pages from it as well. Let me do a kill all -19 to memhog. That will put them in a stopped state. Bring up top. There are the 3 stop processes. They won't show up in top because they're not using a CPU and therefore are not 100% busy. Now if I do a kill all -18 to them, which will send a continue, they'll start growing again. Let me send a 19 to them. Do a PS-EL and grep. There they are. Notice they're in a stop state. The T indicates a stop state. It can also indicate a trace state from like attaching to strace. Let me try an strace-P to one of those things, 51619. Let me put it in the background. Oh, we can see it actually writing. Kill all -19 memhog. Kill all strace. Let's bring up top. It appears when I attached to it with strace, it started running again. let me use a -O trace file, put that in the background. Now let's see. And what's strace doing? PSEL, grep strace. Strace is in a sleep state. Oh, it's waiting for the parent. It's in a wait state. Okay, let me kill all -9 memhog. And that means no matter what, the 9 signal will be seen and not masked by the signal library call. And I got my memory back now. Now, let's bring up top. So I got all these code 9s running. They're 9 gig in size. You add them all up, there's about 10 of them there. That would add up to 100 gig in my reservation. Let's see what star-R1space5 shows. I don't have any reservation showing up there. Nothing committed. IPCS-AM shows the 11 threads that are attached to it. Kind of waiting for this to quiet down. I think what I'll do is change my sample interval. Okay, so I'm waiting for, okay, now I'm off. I'm down in here. So I lessened my sample interval so that I could get rid of that big storm. And now I'm down into the actual processes. Notice that mapped is in there and cached is in there. So again, anything that is attached to SHMEM is going to show up twice. Now watch, I'm going to kill all code 903. My mapped has been released, but my cached has not. IPCS-AM shows that it is still unattached. IPCRM on the ID there, 163844. This one here. Removes that one. And now my cache, clean. And now my IPCS-AM shows that I don't have anything unattached. Okay. I've cleaned up my memory. I do still have a slab going on, but I'm going to leave that alone. In fact, one of the things I'm going to do now, this is bad, but I want to see what happens here over the night. I want to change my min slab ratio and allow the kernel slab to get bigger. There's also, remember that fragmentation, there's a fragmentation metric that says, this is basically centipercent, but if I am 100% full on a node, that's when we're going to start defragging and compacting. The default is 500 or 50%. So if I get 50% of my memory full, the compaction should start doing a move page migration to do garbage collection and basically defrag memory. And in particular, when I have a large slab, it's doing a heavy defragmentation on the slab. So I'm going to do a sysctl-p, and now that'll pick up next time I boot. So one of the last things I want to do here, I'm going to cd/dev/0 into, and this is going to be bad, /home/tng02/file_r. I'm just going to pick a random name for it. This is going to write a file into the NFS file system, which is going to be slow. Let me bring up top. I'm going to get rid of free for the moment. And there's my dirty going on, and riding right on top of it is write back. Can't even see the write backs right now. Let me get rid of the slab. Let me get rid of buff mem. Let me get rid of the paid anon. So there's my dirty data. Oh, we just had a flush. That data has gone from dirty to write back. Now that flush will happen after 30 seconds by default. What do we got here? 49:32, 59:03. That was a 30-second window there before we had a flush. And now that dirty data, let me get back to write back. All that write back data has been marked to flush, is flushing to a file system that isn't big enough to catch it. But there is some NFS unstable in there, so we went dirty. Then we hit a flush threshold, which was a 30-second threshold. We'll talk about those flush thresholds Thursday. And that's when we marked everything just like a sink. The flush team would wake up and said, this stuff's 30 seconds old, let's flush it. And it got marked as write back, and now it's slowly flushing to NFS unstable. And from there, once it flushes off to the NFS server, it's going clean. Having a little trouble just getting a PS to run. One of the things here now, NFS is not a good thing. PS is going to a file. It's hit a file that has a NFS file system open. So if there's a file that somebody's logged in as guest, and his process has home guest as a directory or an open file for standard in, standard out, standard error being directed or something, it's going to stall. And I'm in deep trouble now because I can't even kill the process until this flush is finished. PS-E, and it's stuck on the flush daemon itself. Can't even get out of that now. Everything is non-interruptible. Control-Z won't even work. This is why you don't want dirty write-back NFS unstable to get out of control. Also a reason you don't really want NFS. Let's see what's going on here. So I do see I/O wait time in there a little bit. Nothing on swap. My memory is all free. I don't see any block disk activity going because I'm going to NFS. I wonder here. I'm going to add a tab. NFS version 3. I think we're 3, not 4. And I'm a client. Let's see if we can catch anything here, all the different types of requests. Not real high. See which one that is. Make node, no. Get attributes, yes. Get attributes is one of them. And client requests, no. There they are, writes. So we can see all these client write requests going off to that server. But they're not high intensity. Let's see what happened to Numalink. No, we don't have any real Numalink activity going on. Again, the NFS is throttling the I/O back, so my Numalink isn't going to be busy because the network interface is, or the NFS itself is busy. So I can see that I've got more and more memory going to the NFS unstable and that flush finishing. Again, I'm kind of in trouble here. I can't get any sort of response. good reason not to use a serial console. Let me see if I can log in okay. Let me try logging in as guest first. And we could time that. It's going to go slowly, going for message of the day and stuff, but once it gets to the home directory stuff, it's going to be in trouble again. There, I got logged in finally. Let's see if top runs. Okay. All those code 5s going. Let's see what IO top shows me. Oh, IO top choked. That's interesting. I may have to report that because I'm doing network statistics or something. Operation not permitted. Let me change here. There we are. The bottom line, I can see my code 5s that are doing I/O here, but I cannot see the DD. Let's see if the DD is still around. And again, I'm stuck on the flush daemon. My process is either running, runnable, or sleeping. That PS command, if I can catch it at this point, I can't. Let me try logging in again. I'm going to go to NASDAQ server, which is the home directory for this thing. Let me just bring up top here. There's the NFS daemon that's handling this I/O. There's the file that I was creating. How big is it right now? About 5 gig it looks like. 6.6 gig. No, I'm sorry. 4.8 for the file R. Rounding that. Let's see if top disk is showing anything on this system. No disk activity there. I/O top. I do see the NFS daemon doing a little bit of I/O in the megabyte range. I also see the flush daemon kicking in. Let's /proc/mem info. I'm on the server. And there I do see dirty data. I got about 500 meg of dirty data. None of it is marked as write back. Now this is a client or a server, so there's not going to be any NFS Unstable. So I can see that file slowly flushing, going to NFS Unstable, but it is flushing because the cache clean is growing. So it went from dirty to write back to NFS Unstable. Now those are topped off, but it is moving off to the cache clean because cache clean is growing. And none of my other windows are responding because they're stuck on the flush daemon. This is what I call the flush choke. We're choking NFS and everything is backing up because of that. Can't even do a Control Z there. So once this mess kind of starts, you're in trouble. You can't kill it until all that dirty and write back is out of memory. Let me SSH root at Floyd 3. Just try to kill all on DD. Let's do an IO top. Can't really see anything there. just those code 503s. cat/proc/mem-info. Oops. So there's that NFS Unstable. I've got 2 gig of NFS Unstable. What have we got here total? About 4 gig of data that needs to flush. Let me add everything else back in. Whoops, looks like we just had a flush to the NFS server. A whole bunch of that NFS Unstable just got out of memory and was picked up by the NFS server. And now I can see this other write back is slowly growing into the NFS Unstable again. Let me change my sample points. So again, I can see this file is still being written, still being generated. And I'm seeing cache clean grow there. Let's bring back buffmem. No row buffmem here, and then let me add in free. And all this is happening down here in the low end. So I've got plenty of memory, but because I bottlenecked on NFS, lots of things that have to go through NFS directories and stuff are stalling out. I'm just curious if I can catch this here. I'm going to do an echo T into /proc sysrq-trigger. That's going to print out the stack trace for things that are sleeping. Again,
I'm wondering,
running, runnable, or sleeping. If it's running, perf can tell me what it's doing. If it's runnable but not running, then I've got to look at the run queue in proc sched debug info. If it's sleeping, then I've got to look at the sleep tracebacks, and that is done with like a crash command, the wchan field in PS or top, an echo T into sysrq-trigger, or lastly dropping into KDB, doing a BT for backtrace, or BTA for backtrace all, or an arch KDB macro that calls everything. Just going to do -f on var log messages.
Hello?
Yes.
Yeah, I'm just wondering that putting that thing into that you just did, is that fairly safe to do in a running system? Because
yes.
I know you said some of the other stuff isn't.
Yes.
That one's pretty safe. Okay.
But an echo T, it's a sysrq. You can do it on keyboards and stuff too if you're directly attached. But that's not going to panic the system or create some sort of PCI timeout or anything.
So it's safe enough then?
Yes. There will be a little bit of an impact as it's collecting it and stuff, but you're already in a bad situation. So here's a situation where everything is bad. Let me wait for that to finish, and then I can go in and take a look at things. I can look at the PSs and things of that sort. So if it's sleeping, the echo T is the best way to look at everything. And sometimes one thing is grab the lock, and then everything else is sleeping behind the lock. And you oftentimes want more than one process traceback. So this is giving me all the sleep stuff. Oh, let's see what we just had here. Here's a PS command that was stalled out. It's non-interruptible in the D state. Kind of wraps here. But it was doing a system call. So the PS command was going in to get status. Found out that the status for it was off on NFS, and that's why the PS is stalled out as well. So the PS is sleeping on page, waiting for something to come in from the NFS server, trying to get attributes. So it's sleep, waiting for I/O from NFS. Let's go to overview. Can't really see anything there. If I do a green to take it out, since this is 100%, it won't make any difference. I still can't zoom in. There's a plus here. But that doesn't really help me much either. NFS. We can see some NFS. Was this the attributes? There was the attribute storm that we happened to catch, it looks like. What else we got going here right now? I'm just taking ones out to find out which one that is. There it is. That was the write request. And now it's printing out sched debug. So if I VI and var log messages, it's also in dmessage, by the way. Let me do that. Dmessage into a file, VI the file, /ps. There's a ps command, and here's the traceback we were just looking at. sysrq is going to read it from dmessage and then write it into var log messages. Find the other one. There's another ps, same thing, stuck on NFS. Let's see if they're running under IO_sched. So there was the code 503. There's another code 503. There's a DD. So the DD, by the way, is still in there. The kill doesn't work because it's non-interruptible. So I'm in trouble here because this thing is going to reach a file system full at some point. So it's trying to do a write to NFS. It's in a D non-interruptible state. It's in IO_sched, so it would show up in the wait IO. Let's see if we can catch that. *, good enough, 1_4. I'm not seeing a whole lot of IO wait from it. Let's check the load level. That probably hasn't changed. 130, 130. That's where we've been from those code 503s. Now, even worse, let's go into home TNG02. We're going to come back to this IO stuff on Thursday, but I'm just trying to show you how different things in meminfo can have meaning. So I had big file in there. By the way, the response is tolerable right now. See what we got going on up here. Get rid of free. So it looks like there we are. All my NFS Unstable is gone. All the write back is gone, and my system is kind of snapped back from that now. Where I wish I'd had the last 5 minutes instead of the last minute. Okay, ps-e, let's grep for DD. So again, DD is now gone. I can't do anything until that file is removed or until all the flushing is done. So let me do this again. Put it in the background. Notice even doing an ls-l is slow up there. Let me get rid of free. So there's my dirty and write back that happened right away. Let me get rid of the slab. Let me get rid of cache clean and on pages. There is my dirty that got marked to write back, and now it's going to NFS Unstable. And I can't get anything out of this system right now. SSH to guest at NAS-server. No, I want to go in as TNG02. So I'm not dependent here. There's my end file. Let's do a watch. Not really growing right now. Oh, what's going on down here? Looks like I got a bigger dirty now. More dirty data. Flushing. I did finally get an ls-l, but it kind of broke out. There's all my dirty going to write back, going to NFS Unstable, about 2 gig of write back data. And can I catch the end file? I'm watching for a flush here. So when that NFS Unstable goes, if I were going and do a sync, that's not going to help me either. Again, be real careful. Don't do syncs and things like that on your serial console, because you're going to need your serial console for other things like a clean shutdown. Waiting for the NFS Unstable to indicate a flush occurring. So the write back is being moved to NFS Unstable, but NFS Unstable is still staying even. None of this memory can be recovered or trimmed until it is flushed. Dirty write back NFS Unstable cannot be trimmed. Waiting for a flush here. I got 7008 up here in the file, last couple of characters. Now my file system could be filling up. Okay, looks like writebacks have stalled out. NFS is not taking anything more. Let's see if we can get a flush here. There, a flush just happened. I'm not seeing it go to the end file yet. I got out of main memory, but I still have to have a flush occur on the NFS server. See if I can catch this before it changes. So I do see a flush daemon happening. We just get a flush. I'm not seeing anything there. Let's see, cat/proc, mem info. Dirty was at only about 350 meg. Not sure why I haven't seen that thing yet. Let's try a sync here. I don't know why. I thought nfile would be growing. Not seeing that right now. Let's go back here. PS-EL, ref for DD. DD is still there. Let's do an S-trace on DD. Oops. Oh, I need the PID. Oh, stalling out again. And that's because we got a whole bunch of write-back data going again. My file did grow up in size. I'm not sure why it's out of sync right now. But let me do something else now. Remove nfile. File is gone. I'll try it on just home. So we're at 65% full, 8136 used. I'm not going to be able to kill that thing, or the file is removed, but the disk space is not recovered yet until this flushing is done and the process has been killed. Same sort of problem. Let's see, kill all DD, kill all -9 DD. Let's see here, IO top. Don't really want to do a PS-E at this point. Still at 65%. What if I do a sync here? Dropped a little data, but I don't see any real effect of the sync. I've got cache clean out of the picture here, but here's all that data that we're writing off to the NFS server, so it's going dirty, write back, NFS unstable, and then clean. And you're able to see the flushes going on here too. Put that in context with free, put in the slab, put in the non-pages. Let's get rid of free just to get down there. Still 65% there. The sync is still running. Going to home, TNG02. Again, coming in through Floyd 3, that LS is going to be stuck. Again, it's going to be sleeping on I/O. And we're slowly wedging ourselves as everything sticks behind that NFS IO_sched lock. DF-H. Oh, home went down to 56 now. Well, that's because I removed the other two files. Sorry. They weren't being flushed. They were left over from before. Now let me get out of here. I'm trying to clean up this mess. I can, let's go off here, try again. Let's do a BC free -A, if that trims my cache. And there I can see my cache being trimmed. That's all back. But I'm still stuck on flushing this dirty write back NFS is going to an NFS server. I'm at 56% there. And again, I'm in trouble here. I can't kill that DD command. Bring up top. I do have all these code 5s running as well. I'm just going to ignore them right now. Small dirty, but mostly write back. We're in the 600 meg range right now. Waiting for the dirty and write back to stall out. Wait for the disk space to free up and the process to show it's terminated. Getting real close here. Anyway, I can see some Numalink spurts in there. See if I can correlate them. Can't really tell here and here. And there was data dropped at the time. I'm not seeing any sort of flush there. I don't see any compaction going on. And no real change in NFS. There was a burst of NFS. Oh, we just had a big burst of NFS now. And my NFS unstable and write back are gone right now. I'm not seeing any dirty right now. Let's get rid of cache clean, try to zoom in there, get rid of slab. What's my time right now? Date, 13/21. But it is still stuck. PS-E. That didn't take too long. This flush daemon, that flush dash, this is a major minor number for the file system that's being flushed. Let's see what top shows me. Nothing really big there. IO top. Still got those code 5s running. Looks like DD is gone. I didn't really see my disk space recover, though. It looks like it just recovered anyway. Okay, I'm kind of done with, we're going to come back to dirty, right back NFS Unstable, sysctl-a, grep for dirty. These are the thresholds we're going to talk about later in the week on Thursday. This is the one that we were seeing flushing. When it was 30 seconds old, that forced the flush. The other one that starts flushing is this one. When I'm 10% dirty, I start flushing. Okay, so I want to move on. That's kind of done with the demo portion, and I want to finish the labs. So to begin with, when we were before break, because transparent huge pages are on in this kernel, I have a compaction routine that was preventing me from allocating memory and allocating swap and getting to So in order for the exercise to properly work, I need to turn fragmentation off. So I'm going to go into slash, first of all, to show that, or defragging off, to show that I got transparent huge pages, THP and slash proc slash vmstat. Shows the THPs are in there, and compaction. Now these might have been added to vmstat after the actual implementation. I am running the latest kernel here, and it actually has a patch in it for a memory C group hang that I had last week. But basically this is the current kernel you would get if you do an update for SLES 11 SP2. I'm going to go into slash sys slash kernel slash mm for memory management. And here again, there is a transparent huge page thing in here. And this tells me whether I want defrag or not, whether I want transparent huge pages enabled or not. Let me cap those. And I can see defrag is always, and transparent huge pages is also enabled. Let me go into K huge page D. This is all new stuff that's being added to the workbook. I'm going to grep. So huge page, K huge page D is a daemon that is doing coalescing and splitting, or collapsing and splitting of pages. So if I have a bunch of small pages, the huge page D is going to try to collapse them or coalesce them into a single large page. If I grep huge and slash proc slash mem info, my default huge page size is 2 meg right here. And notice that right now that I do have 1.2 gig of transparent huge pages. That's the transparent huge page counter. But this is going to get in the way. Basically the garbage collection or compaction of memory. I don't know of anybody that is going into these huge page D statistics yet. I was looking up here how long I'm going to sleep on an allocation to be able to give a huge page option, whether defragging compaction of memory is on or off, how many scans I've done looking for pages that can be coalesced or collapsed. Don't know anything about max PTEs, none yet. Had 157 pages that were collapsed into a huge page of 2 megabytes in size. When I do look for pages to collapse, I'm going to look at 4K pages at a time. Then I'm going to go to sleep for 10 seconds, it looks like, before I pop up and start looking for more pages to collapse. Now, all I want to do is turn off compaction here. So if I cat defrag, I'm going to echo a never into defrag. And now I can see it's marked as never. Now I had an init.d script to do this. If I do more on my ITC init.d, this is what caused us problems yesterday. And all I'm doing in my boot script is turning off compaction. So now that that is off, let me just see what I got going on here. I do have code 5s there. I'm going to go to the workbook, and we'd left off on page 3.5 playing with program sizes. And we'd shown that these code 4s were reserving 2 gig, but only using 200 meg. And I was trying to write an script. And this one is like 300. Let's do 200 here to run this code 403. I've got defrag off, so let me just try this now. Let me go to PCP here. There's my memory usage going on. Let me take a look at my system time. Very low system time because I got defrag off. I went 100% user utilization. And there's my memory growing. All there, by the way, is the kernel and process space. So there I got about 40 gig of these things. No paging. Well, let me get rid of THP stuff here. So I'm not seeing any indication of pages being collapsed or anything because this process is 200 meg in size. Bring up top. So I got those code 4s. They're only allocating 200 meg out of the 2 gig. Now, something you need to be aware of, I'm going to go to F, and there's a field in here called swap, and I'm going to do a P. That swap field is not saying that it's on the swap device. Look at my swap is 0. I have nothing on swap right now. Yet this field is showing a swap indication. Let me get rid of a couple of these other columns that I don't need. I don't need priority or nice, and I don't need share. I'm going to do a Shift capital W to save it off in a top RC file. So these things are all running. Now they're only 33% CPU utilization. Not sure why. Let me go back to F and check on the CPUs that they're on, J. I'm going to try sorting by the CPU. I did a capital O, and I want to sort by the CPU, which was J. So I can see that I've got, let's see here, priority. Look at, I've got 4 code 4s all on the same CPU. So that's why they're not getting 100% CPU utilization. Did I ls/dev/CPU set? I don't have any CPU sets in place. ps-e. Oh, because I've got 64 CPUs and 200 code 4s that I spawned off, they're all going to be sharing a CPU, which results in CPU wait time. I want to do this, get delays, -D for delay, -P, and then let me pick a PID randomly, 52543, and I'm just attaching to one of those code 4s, Let me do a watch on it. Not seeing any CPU wait time accumulating on it right now. Now, I was trying to push this all the way to fill up memory. Only got about a third of the way there. Let me go 700 of these things. So I've got fragment turned off to make it easier to get to my out-of-memory killer situation. But I still have transparent huge pages turned on. There's my anon pages. And a little bit riding on top of it for anon huge pages. But again, this is not getting anon huge pages because it's 200 meg. That's too small to collapse or allocate in huge page chunks of 2 meg. That would be wasteful to allocate 2 meg for, allocate 2 meg for this particular process. Looks like I still haven't gotten all the way to all of my memory. I'm trying to push it to swap. I don't have any swap going yet. I'm trying to push the memory. Still waiting to get out of memory into a swap situation. Well, while I'm waiting, let me add in a tab here. I want to do two things. I want to put in here, let's see, paging. These are pages going to the swap device. I don't see any numbers visible there yet right now. I'm almost out of memory. There we are. It's just a funny color, but it's all, I can't tell exactly. That looks like a 0. Let me also get another chart here. This time I want to get mem free. Let me go to util. There's free. Put that in there. There, we're now starting to swap. And my memory is free in the 300 megabyte range. I'm seeing some swap outs and little swap ins. Also want to get one more plot here. I'm not sure that I can actually do it by partition, maybe. Let's see. I'm looking for the swap partition, but I want to know megabyte transferred to the swap. I'm getting number of I/O operations and stuff. I don't know why it's calling this page migrations up here. That can't be right. We're just looking at swap ins and swap outs, not page migrations. Nothing there. Let's check this one. Blank, pages in, pages out, used. But I really don't see anything that is a bandwidth type of thing. Okay, let me see if I can get some of these windows open working here. I'm in a bad situation now because I'm out of memory. I'm in a memory pressure situation. Look at memory here. So I can see all my memory's gone. I do see that the slab grew because of this large, actually I'm sorry, that's page tables that grew. And here is my swap slowly growing. I can see the writes going on for the swap. I'm dropping data like crazy right now. And in paging, I can see where I'm trying to do page scans, looking for pages to trim. Looks like there was also some compaction stalls and stuff going on there. Come on, give me back. It's stalling out on me. I haven't seen any unevictables. I'm just going to get rid of that chart. And this thing's having real trouble keeping up with me now. It looks like that green was slab scan. Let's just double check. Now, one of the things I wanted to do, top disk. Again, because my cache is 0 and squeezed down, I'm having trouble getting shared text and memory space for shared text. Even my probe is having trouble here. Let me try if I can get the swap. So here's my I/O. Looks like I've got swaps going on here. What I want to do here is try to change a page-cluster setting. There's a sysctl parameter that says what's the size of the swap. If we do our swaps in larger chunks, that will reduce. By the way, we should probably have some page splitting and collapsing going on too. Can I see that here? I'm having real trouble getting any sort of response right now. Data's just dropped. See if I can catch something. Memory. Yeah, I'm still not out of memory. I still have memory available. I am not in an out of memory killer situation yet. So there's a field here, min-free kbytes, that is often adjusted, particularly on smaller memory machines. The amount of min-free kbytes it keeps open is actually used by the kernel for emergencies and for the TCP stack trace. So I'm having real trouble getting anything out right now. The Ullman swap situation like this is the worst thing for interactive response. Swap is still not full. Can't even get sysctl in here. Let me try something else. I don't want anything else on the console. Control right bracket S to steal. Still no response on the console. I am not in a CPU set situation. We'll do that on Friday. I'm going to do an escape shift KDB and type in summary. Now, one thing wrong in the summary command is it's not printing out shemem. I don't know if I have any shared memory as a problem. But here's my mem free was in the 330 meg range. And my swap still has memory available on it at 3.5 gig. Let me just type in a go. I wish that Linux had a min buffer cache size, min page cache size, so that when I do a trim, I don't trim the cache down to 0. I leave some room in the cache for shared text. I've actually got about 55 meg for shared text right now. Oh, that DD, we finally see a termination of the DD that I had going earlier. Finally shows the kill. Still no response in here. We can do an escape shift KDB. And I'm going to do an arch K. Well, before I do that, let me do a BT for the current process, the actively running process, which is the shell. And the shell sitting here took a page fault trying to allocate pages, so it's trying to get memory to bring in the shell, and that's resulting in there's no memory, so it's got a free. And the first thing it tries to trim is the kernel slab in the shrink zones. Then it tries to trim the inactive portion of the cache, then the active portion of the cache, and then it started swapping. In this case, it had to add something to swap, get a swap page, and it's stuck in a scan map. Now the kernel is breakpointed at this point. Let me do an arch KDB. This is also going to dump D message. Any sort of echo T will be visible there. There's our get debug. And then there's all the individual current tracebacks, not the ones that were in D message. We can go back and look at this trace later. Now, it is possible when you're in KDB to do a kill. Unfortunately, I've got too many things to kill. There's not a kill all. These are all the sleep tracebacks. There's all the code force that were actively running, so they have no traceback. Just a thread return. Should be finished here quickly. Now, what I wanted to do was change min-free k-bytes, which was showing at 300 meg, and change min-free k-bytes like larger and see the effect, or smaller and see the effect. Everything I'm seeing here is in a shrink trying to allocate. Okay, I got my KDB output back. What's the last one that I've got here? GDM, trying to get in. Again, we're not in an OOM situation, but we're still deadlocked because everything is trying to get swapped. Everything is stuck on this shrink and then trying to get this scan swap map. Let me do a go. It should return me back, but again, everything is pretty much stuck here. I may as well, I did get a response here. Let's do a kill all, code 4. and see if I can get my system back. Is PCP responding? PCP still dropping data. We were not in an OOM yet. The logical swap wasn't full yet. It could be by now because we're dropping data, but we can't tell. So when we were hitting this out of memory, it was at 300 some meg. Well, that's happening. Let me kill off some of these older. Just trying to clean up some of this. Oh, is my system back now? The kill-outs might have taken effect now. I am in high system time right now. I'm going to do a top sys. See if I can catch what that system time is from before it goes away, and it's gone. Too late. I missed it. So there was some system time in there, but I couldn't tell what it was. We are trimming everything, but I missed what that system time would have been. So all my memory is back now. No paging indication. Numalink is back to normal. Look at, we were up in the upper gigabyte transfer rate during that swap situation. I'm not paying attention to NFS anymore. We got past that problem. And swap. So I now have 250 gig free on swap. Now, there's the sysctl-a rep for min_free_k bytes. And there is, we were close to that at 225 meg. We were in the 330, about 50 meg that was still breathing room. Let me just try, first of all, in the workbook, page 3-5, adding a swap. Let me see what I got for a swap configuration, swap on-s. I do have a swap file and a, let me just remove that thing, swap off -a. Anything that was out on swap is going to have to be brought back in. Let's see what we had out there. There, the swap off is done. Well, not quite, it looks like. There's still stuff out there on the swap. Can't really see with all this other stuff here. Okay, so swap on -s. So all I've got is that swap file. I want to make sure that SDB is not being used or mounted by anything because I want to turn it into a swap device. Still waiting for the swap off to work. Pretty small. Wonder if there's any swap I/O going on. We do see some swap ins going on. This is the stuff being pulled in from the swap devices that I'm turning off. The only way I can tell if a process has pages out on swap is with dlook and grep for the swap. Still waiting. get rid of free here. I still have a little bit used in swap. So notice the used is going down here. And as soon as that is gone, my prompt should come back. There we go. Prompt is back. Memory is all, or swap is all freed up. Okay. Now I got a second disk here. It is being used in my lab. I'm not going to use that disk. I'm going to take this disk instead. I didn't want to mess with data 2. So first of all, let me do an fuser UVM on /data 2, data 1 in this case. You're going to use your data 2 or your SDB drive. Nothing is on data 2. I'm going to U-mount it first. Data 1, I mean. Do DF, not visible there. I'm going to go into parted, type in P. So I do have a fourth partition here. It was currently XFS, but I want to reuse it because my second drive is being used by those code 5s right now. So in the workbook, you're going to do a dev SDB, but make sure it's not being used. I type in a print, and I can see the partitions that are there. What I'm going to do is an RM on 4. Type in P, and that partition is gone now. I'm going to do a make part. I'm just going to go 0%, even though it'll figure it out, to 100%. But I also need to specify it's a primary partition, and it is a swap. Linux-swap. Now it says, wait a second, the closest we can manage from 0 to 147 gig. I'm not sure that I want to do this. Let me get out of there. I'm not going to trust it. I'm going to go unit S. So I can go up to this size. I'm going to go in sectors. So I'm going to do a make part, P for primary. If I have more than 4 partitions, then I have to get into logical volumes. And it's going to be a Linux-swap. And then I want to do the starting point. Let's go right here. Not sure why the prior one is showing something too. 2263060047 sectors, and then go to the end of the drive 286749488. Let's see if that takes. Outside the device, that's a little bit too high. Let's just go 400. And it's going to adjust it to find the closest location, 6048. Let's just go with that one, yes. Type in P. Now, it is still showing it as an XFS file system because there's still a super block out there. So now I need to do my make swap. I'm going to do a make swap -C to create /dev/SDA4. Now this is going to do raw I/O. See if we can catch it here. So my buff mem should grow. Get rid of the slab. Let me get rid of the non-pages. There we go. There's my buff mem right now. Before I do that, let's do a BC free-A. I trimmed all my, well, actually it still has some buff mem in there. Or is that mapped? That's mapped. Sorry. So there's the buff mem. I don't care about transparent huge pages right now either. So now let me try this make swap. Going straight into the raw space. So there we see our buff mem grow. Step 35 on page 3-5, I'm going to add it into FS tab and then use the swap on-A to add it. We've already run code 4s until swapping starts, but we wanted to check the order the swap partitions fill up based upon the priority scheme. Let's do a swap on-A right now. Well, that isn't quite right here. BI, ITSE, FS tab. So I wanted to get a swap here. Here's my swap file. I'm going to ignore that for the moment. Put in /dev SDA4. Swap, defaults, 0/0. Now, is my make swap done yet? Doesn't look like it. Let me bring back some of these other statistics. So there's that make swap command doing raw I/O to create the swap map out there. Having a little trouble getting out of here for some reason. Didn't really check to see how big that partition was before. Data 1, that was about 15 gig, but that's in blocks. These are in 1K by blocks, so it's a 30 gig partition. How far are we to that? We're at 20. Yeah, we're about 20 gig in that raw swap. It should be finished real soon, or did it already? No, not quite. I see the slab growing too. I wonder if I can catch that. I don't know why I can't break out of this editor right now. That VI is in a log wait. Let's try a crash. Oh, looks like it finished now. Finally got out. It was having trouble writing to the journal. The drive was busy creating a swap device and therefore could not, and also contention because the journal is buffered to raw I/O. So anyways, it's too late to catch that now. Still have the make swap going. Let's see what make swap is doing. Oh, I thought we would, let's get rid of this here. Thought we'd be just about there because it was a 30 gig partition. We're starting to get some messages here. There's the 30 gig partition, and there we see the raw I/O now going away. So that make swap is done. Let me do a swap off dash A, swap on dash S. There is no swap at all right now. Also, let me do something else here. dd / dev / 0 into / scr / swap file. Suppose I could have given it a size, but I didn't. That's good enough for me. Got to wait for all that dirty data to flush. You can see it here. There's the dirty to the flush. There we are. Got my prompt back. See what a sync does here. There, it's all flushed now, and now cache coherent and clean. I'm a little surprised it took so long to flush that and marked it as flush before the flush actually showed up. Okay. Now, where was my min-free K-bytes? So let's do a sysctl-w dm.min_free_k-bytes equals, let's go to 2, 1, 2, 3, 1, 2, 3. Now I want to push and see what happens here. There's also a sysctl-a for page-cluster. And I'm going to try upping that one. This is the size of the swap IO requests. Let's see what 8 does. Let's see what 16 does. Doesn't seem to care. I'm just wondering if it will detect something that's too big. It doesn't care what it is. Let's see what it actually printed, though. sysctl-a grep for page-cluster. It did take that number, but I'm not convinced that that number is what it's going to do. So let me add those swap devices back in still. I did have I have to do a make swap on /scr/swap file. And that was a a 3 gig. Looks like that was a 3 gig swap. I'm going to edit my FS tab again. And I've got that one, and I've got this one, and they've got different priorities. So let me put this one as a pri equals 5. So I'm going to fill up the swap file first, then fill up the SDA partition 4 swap, then fill up the root swap. So now let me try running that script I have. And I'm about done here for the day. Oh, I didn't add swap in yet. Let me do the swap on -A to add the swap. Did not get on before. Now let me do the swap on -S. Let me try watching it. Get this a little bit wider here. So I'm waiting for U's to start growing. Let's go back to PM chart. If I'm not quite there, I need to fire off some more of these code 4s. So I've added both a raw swap and a swap file and used priorities to do things. And right now I'm just waiting for the last thing. There is an overcommit memory lab. I'm not going to do that right now. So let's see what's going on here. Oh, I don't have my swaps added yet, it looks like. Wait a second. So I am getting into the swap, starting to swap now, but let me do the watch. Can't get anything out of that. Also wanted to check if my min-free K-bytes. So there's my swap filling up. But I really didn't get to see the priority order. Let's see what swap is showing here. Yeah, I can't really see where my mem-free is on this particular display because the gig is making it too big. So let me change the sample interval. I'm not getting any response here. There we are. Edit. Catch up, catch up. Samples. This is to get the big stuff off the chart. C4. Still doesn't, there we are. No, there we are. So notice the amount of memory that is showing up as free right now is 2 gig rather than the 300 meg that I had before. That's showing the min-free K-bytes is in fact working. And then the other thing was that we really can't see here because the system is kind of too slow was with top disk. And I'm having trouble doing anything at this point. Now to find out whether a process has pages on swap, assuming I can get to it, dlook, let me find a ps-e, grep for code 4. Looking for a PID here, then run dlook on it. Okay, there were some code 4s. Let me just 56533. And then uppercase swap, and we should be able to catch, assuming dlook can get running too, should be able to catch how many pages that thing has out on swap. And there we are. Oh, I forgot. dlook's writing to standard error, not standard out. So let me redirect that into a file. Again, we're in a memory pressure situation. For anything that needs the cache, it's going to have trouble getting cache memory. What we got going on down here? Can't even move this thing easily. So I always start off with memory as the first resource because that's the one that is going to impact your response and your performance the worst, and also get you into trouble with out-of-memory killer events. Okay, there was a question on page 3.6 about if you're swapping to the second disk first, can you tell a performance improvement? I would expect not, because the I/O is not the problem. The fact that the cache is under pressure and small is the problem. No breathing room to bring in executables. I can't even get that X to work. So at this point, I think what I'm going to do is just call the demo portion of the lab done for the day, and let you try to do some of the labs and replicate the labs that I've been doing and play some of these games. Does that work for you? Are we still
yes,
there?
it does.
Because I kind of went too long yesterday, and I'm at the point where I've gone too long today, too. So let's start tomorrow morning, same time, 9 o'clock Mountain Standard Time, and we'll move into I/O. Okay? Now, I will be on email to answer any questions. If you need it, we can go back to a WebEx session, but at this point, just send me email with any questions on this portion of memory management. And we're going to come back to the flush daemon and trimming on Thursday. Right now, we were just primarily trying to look at the procmem info and how data is interpreted there, having to deal with compaction and transparent huge pages, and also swapping and out-of-memory killer. So with that, I'm going to stop the recording and in the meeting here, and we'll see you tomorrow morning.
Okay.